breaks and stuff, please feel free to ask him about all our cool math stuff that he does. So I'll let you go with that.
All right. So while I do have a talk prepared to advocate the use of R, presumably you've all come here because you've already heard of R and you're interested in it. So I'll just go straight into using R. So the first thing, oh, go ahead.
Do you have a mic? Can you turn it on? The reverb in this place is pretty high.
Okay. I don't see. Oh, here. It's a mic. Test. Oh, wow. Great. And that sounds okay with you? Perfect. Okay. So, well, I'll do a little spiel. So R is a statistical programming environment. It's a programming language that is used by a lot of professional statisticians or research statisticians to implement their ideas. Usually, the latest cutting-edge statistics are available most often in R first, and then ported to other packages and languages. What's nice about R is that it's both free and open source. So all the algorithms that are provided, any code that anybody provides, is auditable by anybody else, unlike other statistical packages where you just have to trust that they've implemented things properly, and there are documented cases where you can show that some professional paid software packages are not doing things properly. So R is great because it's auditable. It's great because there's a large community of users that provide support to one another in various forms that I'll show you online. It's also great because, as I said, it's the forum in which a lot of cutting-edge statistical techniques are most immediately available. So there's a lot of packages that you can install for R for custom algorithms. So in terms of getting R, let me get just a quick poll. Who here, well, I can see probably through the computers, but who here is a Mac user? Typically, yeah. And are you usually a Mac user, or you're just using that for today? Okay. So PC users, so I guess Windows users I should make explicit. All you guys, you're all Windows. And anybody use Linux? No Linux users? Okay. So if you're using Mac in the PC, you're going to be using so R is something that's just at its most basic level, it's just a command line prompt. That is, you can type things and they get evaluated. It's just like a real-time calculator. You can use different graphical user interfaces for R. There's one built-in, when you install R for Windows, there's one built-in, so they give you a graphical user interface. That gives you nice buttons to click to load files and things like that. And ditto for the Mac. The Mac also has access to the direct command line, but we won't talk about that. There's also in addition to well, I'll actually just go and show you where to get R. So if we open up a web browser, you can follow along by doing it on your computer, or you can just watch here. Later on, I will get you to actually do things on your own computers. But for now, you can just follow along or do what you'd like. So I'm going to just search for the letter R. And Google is smart enough, and it knows that R is a popular enough statistical package that it's the first hit. So we can click that, and it brings you to a site that's from the 1990s. It's got pretty bad rendering of the graphics, and it's got frames, which is kind of old school web design. This is the page for R. It has its design is mostly a product of people wanting to work on R, not websites. So it still has a lot of useful features. So there's these menus over on the left here. There's what is R. That's just a little spiel about what R is all about. Some notes on who are the main contributors to R, some screenshots, news on what's on R developments. Most important is this link over here. It's called CRAN. That CRAN stands for Comprehensive R Archive Network. So if we click that, it's going to bring up a whole list of, quote, mirrors. Mirrors are just, because R has, in itself is a somewhat big file, but it also has a whole host of packages associated with it. It would really slow down things if it was only a single website somewhere hosting all that content. So what researchers have done is put their own websites up that simply represent a complete copy of what's on the main archive. So this makes it so that not everybody's going to the same place to find everything and therefore clogging things up, but it also means that you can connect to your geographically nearest mirror and have get your downloads a few milliseconds faster. So the nearest one to us is probably U of T, so we can click the canadaprobability.ca/CRAN, and that will bring us to the the nearest mirror. But all the mirrors look the same once you get there, so it doesn't matter which mirror you actually go to. It just will save you a couple milliseconds by going to the one that is actually nearest to you. Oh, now that I say that, I actually think that the Toronto mirror is down. When I looked at it this morning, it wasn't working. So that can happen sometimes. So I'm going to instead click the Dalhousie mirror, which is up. So, pardon me? Yeah. Yeah. So so again, we have a rather old design for the website. We've again got these links on the side. We can change mirrors by clicking the mirror. We've got the what's new. Now we've got a few more things. We've got a task view, which I'll talk about in a bit, some search. But most important for us right now, in terms of just me showing how one would go about installing R, is that you've got these nice, at the top, links to downloading R for the various platforms. Won't go over downloading R for Linux. There's nobody here, and presumably anybody using Linux is savvy enough to know how to actually manage that stuff themselves. But we've got links for Mac OS and Windows. I'm using a Mac, and it's pretty simple to install R on a Mac. It simply download the file that they put at the very top. It's usually the latest version. As of this session, it's 2.15. The version numbers for R change every few months. That is, they release an update to R that fixes a few usually obscure bugs or maybe implements a slight speed up of how R does its computation. So I think the next one is due. Well, the last one was March 30th, so the next one's probably due in the next month or so. So I like to keep on top of the new releases, partially because when the packages on which my analysis procedures rely update, they often are using the latest version of R, and there's slight issues whereby if the package has updated using the latest version of R and I have an older version of R, then I might not be able to install the package depending on something. So I always like to just keep updated to the latest version of R. So if you're using Mac, you can come to the Mac side and install it by the package there. That will install R onto your system. It will also give you a nice graphical user interface to R. If you are on Windows, you can click the Windows link, and there's a bunch of links here, but the thing that you'd want is, this is what you want to install R for the first time. So click that. It gives you a nice big link up here, download R for Windows. This again will install R and give you a nice graphical user interface. So these are the official ways to download R, and these will give you the official graphical user interfaces. Once you've installed R, though, you can either use the GUI that they actually provide, or you can use any of a number of alternative GUIs. A GUI that I find is very good for beginners because it puts a lot of things in one place that the official GUIs kind of put in separate places, is something called RStudio, R-Studio. And again, comes up as the first thing. And, well, I don't use this myself because I pretty much use just the command line version of R. I do find that this is best for, this graphical user interface is best for teaching and people new to R. So RStudio is I'm pretty sure it's nonprofit, it's a .org, but certainly it's free again, and they provide a nice graphical user interface. Again, it's for both Windows, Linux, and Mac. If you just click that, it will automatically detect what your operating system is and give you a download for that, so that's nice. What's also nice about RStudio for, I guess, more advanced users is that you can put it on a server and have, as we'll be using, a web-based interface to R. So if you've got a really powerful computer at your lab that you bought, you can put it as a server running R, and then you can even use, say, your iPad to do all your statistical analyses by just a web-based interface. I say iPad, they're working on the underlying code for RStudio to make it work for iPad. There's just a few bugs. Certainly, if you just have a low-power laptop or netbook, you can still use your high-power computer at the lab to do your analysis just by using this web-based interface that I'll show you in a moment. So to show you that, maybe what I'll do is so I guess we'll number off, because you each need to have a unique user ID. So you're going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, see you, Annie, 14. So now that you've got your number, what you want to do is navigate your browser to the URL that I have on the board. It's http://goo.gl. That's just Google's shortener service. And it's ZJYT4. And when we enter that, we get a web page that looks like this. It's a sign-in prompt, and it shows sign in to RStudio. So this is the web-based interface to RStudio. I've got it hosted on a server, and you know your username. So what you want to do is type in your username. I'm going to use the user 112, but whatever your username is, type the name user, and then whatever number yours is. So if you're user 1, you just type user 1. If you're user 11, you type user 11. I'm user 112, so I'll type 112. And the password is just the letter R. No capitals or anything. You can click Stay Signed In. That'll just mean that your computer will remember the password. That is just the letter R if you can't remember that password for some reason. So when you click Sign In, you're brought to the RStudio interface. The RStudio interface has multiple panes. It has a toolbar and multiple panes. And this is the case for regardless of whether you're running RStudio from your own computer or running it from a server, as we are here. So these multiple panes show different things. The most important area of R is the console. So you have a little title here. It says console. So this is where you do all your computing in R. There's another pane that you can bring up by clicking this little icon over here. It's a double window icon. That means just split the pane, and this second window here is just a text editor. So these are the two critical, I guess, most critical areas of R, your text editor and your console. So in the console, when you do things, they happen right away. In the text editor, when you do things, they just get stored in a text file. So no computation happens. So the text editor is where you want to write your code so that you can keep a history of what you're trying to do. And then console is where you want to paste your code so that it actually runs. So for example, if I go up here and I say 1 plus 1, and I hit enter, nothing's going to happen. However, if I copy that and I paste it into the console and hit enter, it's going to give me a result. Now you can ignore this part on the left-hand side, this square brackets 1. I'll expand on this a little later, but that square brackets 1 is R's way of telling us that the computation that we requested, 1 plus 1, returns 1 value as its result. And that value is 2. Later on, we'll encounter scenarios where we have results that return multiple values, and it will, this number will change. So again, nothing happens when we type in the editor, in the text editor up here, but things do happen when we type down in the console. I had to copy and paste, which is a little annoying. You have to either do Control-C or right-click and say copy and paste. There's a shortcut for that, though. If I want to run this again, all I need to do is click this Run button. So I can select a bit of code in my text file, I click Run, and it sends it to the console to be run. So that's very convenient. So your text files, when I clicked that little window button, it's opened up a new text file because nothing was open. If I want to save my work I've done so far, so let's say I've done this big, long, complicated analysis, and I've written all the code for it, and I want to be able to save that code so that I can modify it later or do things with it. We simply click the little save button. So save current document, and it will give you a little save dialog where you can say, I'll call it my code. And so I'll just click save. And notice something happened down over here, over in the lower right panel. The lower right panel is a file navigator. So your operating system has a file navigator, folder navigator, that shows you all the folders and files on your computer. You can use that to look at your files, but if you don't want to have multiple windows open, it's nice that RStudio has its own file navigator so that you can navigate your files. So we see now that there's a mycode.r file saved on, if you were on your computer, it'd be saved on your computer wherever you asked it to save. In this scenario that we are in this workshop, we're using a server somewhere else, so it's just saved to your user's folder on that server. So we've talked about the editor window, the console window, the file folder navigator. And the file folder navigator actually has multiple tabs. That is, there are these little words up here that are in square boxes, and it's like if you use any modern browser, they now have tabs, or which in turn is a design feature that's intended to emulate having a file folder, and you've got different tabs that stand out from one another. So the different tabs in the default layout that you're seeing right now, you've got files. Any plots that you create need to be shown on screen. So they'll be shown in this Plots tab. The Plots tab has these nice export options that we'll talk about in a little bit. There's the Packages tabs. Packages will, I'll talk about packages a little bit more, but this Packages tab will show you what packages you have loaded in, what custom code is available to you. I'll talk about that in a little bit. And then the nice Help tab, which has a bunch of links. It's actually just a little web page. And then some options to search the help documents. The final pane that we haven't talked about is this upper right pane. We've got a Workspace and a History tab. So the Workspace tab will list all of the objects we have stored in memory. Right now, we haven't stored anything in memory. We've only done a couple computations. So our workspace is going to be empty. But as we run some commands in a little bit, I'll show you that the workspace will start to fill up with objects that we create. And you can use the Workspace tab to basically inspect the objects that we create. So you can, for example, when you read in your data frame, your data file, you can click its object in the workspace to open up a little data file viewer that shows you what are read in as. The final tab here is a history tab. It just shows all the commands that you've run since you started your session. So we only ran one command, and we ran it twice, 1 + 1, and again 1 + 1. You can actually get from the history tab, rerun any commands that you ran in the past by, again, you'd click one and you'd say to console, and it would send it to the console to be run. Similarly, you can copy commands that you ran in the past to your currently open text file. I don't really use the history tab that much. I mostly try to keep my history in my text file itself so that it's a persistent and explicit record of what I've done. So still with helping you get a feel for RStudio as a user interface to R, I've talked about these panes here, these different panes, and the various tabs within the panes, but there's also an overall toolbar up here. So if I click File, there's a bunch of options to create a new R script. There's some other types of documents that you can create. I won't really be talking about them in these tutorials. They're a little bit more for advanced usage. There's then some open files, so if you don't want to use the point-and-click file navigator that's in this lower pane here, you can open a file through just an open file dialog. There's also the various other things that you'd expect under a file menu, so save as. Not sure what the notebook feature is. I think it's new to this more recent version of RStudio. Again, with the edit, there's undo and all those things. The code, these are all things that will, again, be more advanced for users. Let's see. More important is the options under Tools and Options. So these are the options that specify the overall behavior of how R and RStudio work. So there's a few options that come as default that I actually fundamentally don't agree with. So one thing that R can do is you're working on a project, you're not quite done, but you get interrupted, so you close R. R's default behavior is that it will ask you if you want to save your workspace. So what that means is that if you save your workspace, the next time you open up R, it's as if you didn't quit at all. Everything that you were doing comes back right to where you left off. That sounds like a good idea until you take into account that we're humans and we have limited memory. So by the time I get back to opening up R, I might forget where I was, what I was doing. And therefore, I might start doing something else and forget that there are other things loaded in memory that now start to conflict with what I'm doing now. So I always say that it's best to never save your session. It's always best to start sessions fresh, and starting sessions, to get back to where you are, all you need to do is run the code that you created back to where you were in the first place. It rarely takes significant amounts of time, and I think for avoiding the types of conflict that one can encounter when saving, when always trying to resume old workspaces, it's that extra time that you need to take to get back to where you were is worth it. So I always set this save workspace to never. Similarly, the restore.rdata into workspace at startup is another one that I unclick. These are really the same thing. If you don't have an r.data, if you've told it not to save workspace on exit, it doesn't have anything to restore. So, but I uncheck that just in case. I never save my history simply because I never use it. My history is my text file. So again, I just remove that. I do usually set my default CRAN mirror. So for example, I'm usually in Halifax, so I'll set my default CRAN mirror to Halifax. The only time that is important is when you're installing new things, and it needs to go to the web, to the R servers and find packages. Again, right now, actually, the U of T server is down, so that's probably what you would be using typically, but it's down. So you can either just not set it. I'm just going to leave it. Well, no, I'll click it as Dahazi and leave it as that. So restore most recently opened project on startup. You could do that. That just means that if you have a file open, it reopens next time you open up RStudio. So that's up to you. It doesn't restore anything in memory or anything. It just means that the text files that you had open will come back open the next time you open up R. So the code editing is kind of, I think for the purposes of this, I'm actually doing a screen recording along with this. So for the purposes of the screen recording and having you guys see where my cursor is, I'm going to actually click this highlight selected line. That means that when I'm out in the text editor, it will be a little bit more obvious what lines I have selected. I also don't like this feature whereby it inserts spaces instead of tabs. So in R, people use white space, so space characters or the tab button or enter as helping you keep your code nice and clean. I'll show you some examples of that. There are some people that only like to use spaces, and some people like me that like to use tabs because tabs create more space. So I actually unclick the insert spaces for tab. You can do whatever you'd like. It's really more of an aesthetic thing. And some people like big code to only be a certain width. I don't bother with that. And the rest of this, I wouldn't bother with. But one thing that you might want to play with is the pane layout. So right now, as I showed you, there's 4 panes, and you can actually customize all these panes. You can put any tabs in any panes. Right now, it's set up so that the text console is over top of the, the text pane is over top of the console pane. That's not really efficient because typically you want to have, well, typically I like to have the console in one side of my screen and my text on the other side of the screen, because those are the 2 panes that I am most often working with together. Sometimes I'll pull down the file browser and do something, or look at something in my workspace, or have a plot come up. But it's more often that I'm working either with my text file or the console. So I like to put those in 2 side-by-side panes. And RStudio is nice because you can really easily just tweak where these panes show up. So, for example, I'm going to put the instead of the source pane being in the upper left, what I'm going to do is put it in the lower right, and it automatically knows to then flip whatever was in the lower right up into the upper left. So, yeah, I'd be happy with that layout. There's a few other things that are more advanced features that I won't talk about that much. All right. Well, there is one thing in code editing that I think might be useful. Show syntax highlighting in console output. That will mean that when in the console, when we do commands and get results, it will be highlighted in ways that are, or it will be, the text will be colored in ways that are meaningful. So I will click that as on. Now if I click apply, it's going to save all those preferences that I've changed, and I can click OK, and now I'm back here. So now it's moved my editor down here and my console window down here. You can resize the size of the panes, so you, on the vertical by clicking in between and resizing them that way. You can also resize the horizontal by clicking that way. You can make a given pane disappear by making the pane, by clicking its small pane button. So that collapses that pane. Here's another example. So I usually collapse the upper left pane and the upper right pane, and only click on them when I need them. So to bring them back, you can just click and it comes back. So this is how I typically like to do my coding. I've got my text editor on the right-hand side, I'm writing my code, and I've got my console on the left-hand side. So I'm just going to pull up my notes here. So one thing I would like to do is if we go to the upper left pane and the Files tab, we've got this file here called Workshop 1. If you just click it, it will actually open up that file in your text editor. You know that a file is associated with R, that it's got text in it that's R code if it has the .r extension. You can put R code in any text file, .txt or .rtf or whatever. But if you put it as, save the file as .r, which is the default way that RStudio and most R programs save those text files, it will make it so that any R GUI will recognize, hey, this is an R file with R code. So, for example, having clicked that, it's opened up this workshop1.r file as a text file, but it's we've got nice highlighting, syntax highlighting, so it's recognized that this is a text file that has R code in it. So the first thing to note about this file that we've just opened up is that there's a bunch of hashes and the word math and then some more hashes. The hash sign, I guess number sign, is used as a comment. So R actually ignores anything that has after the number sign. So if I type 1 plus 1 in the console down here, it'll say 2. If I type hash 1 plus 1, nothing happens because R has ignored everything after the hash. I can say 1 plus 1 hash 2 plus 2, and what happens is that it only evaluates what's before the hash mark. So what's nice about that is that we can use hash marks to insert notes and comments to ourselves about what we're doing in our code, which is very important because often we are creating long scripts that are very similar to other long scripts we've done, and it's best to always keep track of notes of what you were intending to do when you created it. Because when you come back months later, you're going to scratch your head at what you were trying to do otherwise. So I've showed you how you can select some code in your text editor and simply click Run, and it runs over here in the console. I'm going to actually minimize this files browser because I'm done with it. So I thought I'd run through some examples of how R does math. So it's pretty intuitive that to do addition and subtraction, we're just going to use the plus sign and the minus sign on our keyboard. To do multiplication, there's no times symbol on the keyboard, so R just uses the star, so shift 8. So if we do 2 star 3, it's going to give us the value 6. There is a slash, so that's the dividing. So 2 divided by 3 is going to be 2/3. To do exponentiation, so 2 to the power of 3, you use the caret, so shift 6. And then that, and it gives us 2 to the power of 3, which is 8. Another useful sort of piece of math, or math operator, is the modulus. It's maybe not something that most people are super familiar with, but becomes useful in some scenarios in particularly programming. The modulus means do a division operation, but just like when, well, I know when I was young and first taught division, I was always told, I was taught division in a manner that never yielded decimals. I always just had a remainder. So if I had, let's see, 10 divided by 3, it would be 3 with a remainder of 1. So modulus is simply asking, what is that remainder? So if I say, I'm actually going to change this to exactly what I just said, 10 divided by 3, and I'll run it. It'll say, if I divided 10 divided by 3, the remainder would be 1. This next example, 5 divided by 2, what is the remainder? That's what that's double. So that symbol there is double percent sign. If I say 5 divided by 2, and click run. Oh no, it's taking up. Oh no. Got a bit of a stall here. Let me pull up. Is anybody else's computer actually running that? Or... Okay. It should just give you the remainder. 5 divided by 2 is interesting. So I guess this can happen sometimes when you're connecting to a remote computer. No, it doesn't seem to be busy. It just seems that my connection here has stalled. So I'm going to try signing out and signing back in. Or I can just close that window. Come back to it. Should come back. Oh, okay. So I've got a blinking cursor. Blinking cursor is good. It means that in the console, it means that it's ready to compute. So let me try that again. So it's example 6. What's nice is that even though my session died, if I have it set up as running on a server, even if I lose connection or something, it still keeps our information. We haven't lost. So I made that modification to the file without saving it. RStudio, being run on a server, kept that modification, and by making the file name up in the tab here red, it's telling me, and it's got a little star, it's telling me that this file has been changed, but it also hasn't been resaved. So that's a nice feature. But again, we're going to try to run that. And yes, okay, so 5 divided by 2 gives a remainder of 1. A nice thing about the modulus, it may not seem super useful as far as, well, we've moved beyond the type of division where we get remainders in our math, is that you can make easy tests for whether something's odd or even, which can be useful. So anything that's odd, when you take the mod 2, is going to have a 1. Anything that's even, when you take the mod 2, is going to have a 0. So if I say 4 mod 2, and I say run, it says 0. So if I recall correctly, we have an example later on that uses that as a trick to speed up our code. So we've done a bunch of mathematical operators. One thing that is important is whenever you're doing particularly math, you want to, and you're doing multiple operations, you really want to use parentheses to specify the order of operations. So if you remember from I guess it would have been probably elementary school or junior high, they taught you the order of operations. Brackets is the first thing that specifies what things go in what order. So the example here demonstrates why it's important. So I've got an example here where I've written code 2 to the power of 3 to the power of 4. Now what's it going to do? Is it going to compute 3 to the power of 4 first and then take 2 to the power of that result? Or is it going to say 2 to the power of 3, and whatever result that is, take that to the power of 4? So it's not clear from just the straight code here. R will have a default, but you may forget which way that default is. So I indeed forget myself. So we've got 2 to the power of 3 to the power of 4 gives you that. Let's instead, if I actually wanted 2 to the power of whatever this result is, 3 to the power of 4, that's what putting it in parentheses means. So let's run that. So that's indeed what R is doing. Let's run the alternate way that R could have been doing it, or that I could have thought R was doing it. So let's 2 to the power of 2 to the power of 3, all to the power of 4. If I run that, it's dramatically different. So this just demonstrates that you really want to specify your order of operations by using parentheses wherever you can, because it can make a huge difference. These are like 20 orders of magnitude difference in the result of those two. Square root is just to the power of 2. Oh, square root, sorry. Yeah, well, it would be, so yes. So that should probably go up in the math examples. So in example 8, I'll put, it's actually not a symbol or anything like that. It's actually a function. We'll get into functions a little bit later, but the idea is a function usually has a word that names it, and then you have parentheses. So square root 9 will return the square root of 9. If I remember my math correctly, shouldn't it also be square root of to the power of, is square root is, no, that's not right. Oh, I said 1/5, yeah, 1/2. Yeah, so that's how you do it without using a function per se. You do 9 to the power of 1/2. You want a cubed root. Yeah, so square root will just give you the square root. Any other types of roots, you need to do the actual arithmetic. But good question, and I should actually say that anybody has any questions at any point, I'm going through something too quickly, or there's something that just you don't understand, feel free to raise your hand and ask. So we've got math. Another key aspect of any computing language is its ability to do logic. Just double checking, yeah. So the way logic is achieved in R is by, well, logic is whenever you're comparing one thing to another and asking, are they the same or different? So to ask if 2 is equal to 2, you'd have 2 equals 2. Now, it doesn't matter if there's no spaces amongst there, or if you have space on either side. Space on either side actually makes it a little bit easier to read. Or you can even have it space on one side, not the other, or space on the other side and not the first. But what you can't have is a space in between those equals. Space in those equals R will tell you there's something wrong. Equals is treated by R as a single thing, so you can't put space in between them. So if we run that, 2 equals 2, we're asking, is the thing on the left-hand side of the equals the same as the thing on the right-hand side? We can obviously see that that is true, and the result we get is capital TRUE. That's R's way of telling you that logical test yields the result of true. So TRUE is actually a special thing that you can type in R. If I type it here, TRUE, instead R will yield the value true. If I instead just type little letters TRUE, R is going to give me an error. It doesn't know what that is. So R knows what big TRUE is. It doesn't know what little TRUE is. Additionally, as you might have guessed, it also knows what big all caps false is. You can actually use a shorthand when you want to talk about things being true or false. Capital T is also known as true. It's shorthand for true. Capital F, shorthand for false. Typically, you probably don't want to just use that shorthand. I'm guilty of it sometimes by being lazy, but it's probably better to type it out completely when you are actually using it in your code. So to go to example 2, here's an example where it says 2 = 1. So is the thing on the left the same as the thing on the right? No, and indeed, when R evaluates that expression, it yields the result of false. So this equals simply asks, is the thing on the right the same as the thing on the left? But maybe we want the opposite logical test. Is the thing on the right different from the thing on the left? So that's achieved by a exclamation mark equals. And again, you don't want to have space in between those two, otherwise R should give you an error. So the exclamation mark equals is treated by R as a single command. So is 2 not equal to 2? False. So they actually are equal. Is 2 not equal to 1? True. So you can do tests other than simply equality. You can look at whether something is greater than or less than. So when it is non-equal, you can evaluate the sign of that difference. So is 2 greater than 2? False. Is 2 greater than or equal to 2? True. Here I think it's, if I recall correctly, it's okay to put, no, it doesn't like. So yeah, whenever you're doing a logical test, it does not like having space in between the operators. So here, greater than or equal to is treated as a single thing. You can have space on either side, but not in the middle. So is 2 greater than or equal to 2? We've already run that, and the result is true. These examples, 7, 8, 9, I've already actually covered. It's just showing you that you can type the all caps true, and that's recognized by R as referring to something that's logical. And ditto with false, and you can abbreviate, but it's probably not a good idea to abbreviate. Well, we'll get there in a second. So if I were just interested in, let's see, it's actually going to be rare that you'll actually type it yourself. Usually you're using your data, you say, I want to evaluate some relationship between 2 variables, for example. So is the value in this one column of my data set the same as the value of this other column? If it is, do this one thing. If it isn't, do this other thing. So you'll never type that true, false yourself. You'll use the test itself to condition the creation of new data or the modification of old data or something like that. I just wanted to show you that you could type in those words, and they are dealt with as logical values. So we've got math and logic. With math and logic, you can do a lot, but without, I guess, critical for making a computing system powerful is that you combine math and logic with memory. So the ability to do math and logic, say at the result, and then do math and logic on the results, and modify those results and create new results. So the example is, I want to do this expression 2 times 3, and then the result of that divided by 10. It's nicely specified, the order of operations by use of brackets. If I run that, I get the value of 0.6. But I want to reuse that 0.6 somewhere else in my code. What I want to do is I want to assign the result. Well, actually, what I've done here in example 1 is I've done 2 things at once. I've done 2 divided by 3, and then taken the result of that and immediately divided by 10. But maybe I want to split that up into different steps. So what I've got here in example 2 is I first do 2 divided by 3, and we've got this negative, greater than, and then just a letter over here. What the negative greater than sign means, it's an arrow. It means assign the value on the left-hand side of the arrow to whatever I put on the right-hand side of the arrow. So the thing I'm putting on the right-hand side of the arrow is just a name. I could have typed anything here. I could have typed bank or row or anything like that. I'm typing A because the A is right underneath my pinky, and it's commonly what I use to assign variables to when I know I'm only going to use them temporarily. So what this first line does, if I run it, it will make the computation 2 times 3, and it will store the result in a new object that we'll create on the fly called A. Now, if we actually go up to this Workspace tab and click it, suddenly we've got things in there where before we didn't have anything in our Workspace tab. It shows here, it says we've got an object called A. And it's inside A is just the number 6, which, of course, we all know is the value returned by 2 times 3. So now that we've got this A stored in our workspace, stored in the memory of the computer, we can do some computations on it. So when I say A divided by 10, what R does is it goes, looks in the object in memory called A, sees what's inside of it, and puts that thing in place of where A was put in the code. So if I say A divided by 10, and click run, it's of course going to be 6 divided by 10, which is 0.6. These are simple examples, but it's intended to illustrate the simple concepts of assignment, which a lot of people actually get hung up on, and I'll go through with some examples that are a little less simple in a moment. So I showed you up here that you have 2 times 3, and then the arrow, and then A. So the arrow pointing to the right means take the result of the computation on the left, put it in something that's on the right. And you're creating this new thing on the right on the fly. It's going to be a new thing. However, you can actually turn that around. You can actually take that same line and flip it around. This time we're going to have a thing on the left-hand side and an arrow pointing to the left, and then a thing and then a computation on the right-hand side. So what this is doing, it's the exact same thing. It's saying create a new object called A. So we've already got an object in memory called A. What this will do is it will erase what's ever in memory called A, and it will create a new object called A that's empty, but then it will immediately put into A the results of the computation that's on the right-hand side. So when we run that again, I'm actually going to change it. I'll say 2 times 5, so that we can see that A will be changed. It will, in the underlying R structures, it will actually be first deleted and then created again as empty and then filled with the result of 2 times 5. But well, that's why I say that you should always have a new session for any new project that you want to work on. So a single file, a single session is a single analysis that you're doing. If you want to switch up, you need to restart your session and start the new file, so that you don't get conflicts between objects that you're creating in different projects named similar things. So if I run this, it creates A, assigns the value 2 times 5 to it. So I've got A and its contents there. So when I say A divided by 10, we run, we're going to get the value of 10 divided by 10, which is 1. So a lot of the documentation that you'll see online with R uses the arrow as the way of creating an object and assigning a value to that object. I'm a little lazy. I don't like having to type 2 things. In fact, you actually have to hit 3 keys to get that up. The shift and then the whatever greater than, less than you want to use, and then the minus. You can actually do the same thing by simply typing equals. So this line, if I change it to times 5, this line is identical to this line here. The only thing that's different in terms of the characters are that instead of an arrow here, I have just a single equal sign. A single equals sign causes assignment. A double equals sign causes a logical evaluation. Some people don't like the use of single equals sign, and most there are scenarios where it does matter, but those are really well, they're somewhat obscure. It's unlikely that you'll encounter them. It's really it's pretty safe to use just the equal sign as long as you understand that the equal sign is not expressing a relationship or it's not expressing a logical test. It's creating it's an assignment operation. So what's going to happen here is that I'm saying a equals 2 times, well, I'll change it again. I'll say 2 times 6. So when we run that, we've got now a again up here, but now it's got a value of 12. And I say a divided by 10. Run that, it's going to be whatever this is, 12 divided by 10 is 1.2. So far we've been creating objects and putting numerical values into them. But you can actually put a whole host of data types into an object. So for example here, if I wanted to store a logical value inside an object, I can do that. I can say a equals true, and I'll run that. And in my workspace thing, I now see that a is being stored as true. If I want to see what's in a without actually looking up in the workspace browser, I can type a. If I want to, for example, if I know this is a logical value in here, I can say not a, which is obviously not true. It's false. Other things we can do, other data types that you can store into objects are strings. So here's an example here where I have the string testing, and it's enclosed by single quotation marks. So if I type that, now we've got the object A in our memory here, and it has the contents testing. It's actually, in memory, it's being stored as having surrounded by double quotation marks. The quotation marks, whether single or double, simply tell you that this is a string. This is just a bunch of text. It's not being interpreted as a logical or as a number. When you enter the string and when you type the string in your text file or in the console, it doesn't matter whether you use single quotations or double quotations. So if I type this one, it's got, well, the string is single quotes are easier to type. And that's true, and that's why I actually always type with just a single quote. It doesn't matter whether you use single quotes or double quotes. I tend to type with single quotes simply because it's one less character to type with my fingers. And again, I'm lazy. So an important feature that I need to reinforce with regards to the idea of assignment is that assignment is impermanent. You can always modify assignments. As we've seen, we've been doing all sorts of assignments to A, and A has been changing as we've been doing these assignments. So assignment, let's go through this example here. So if I run just these first 3 commands here, run. Oh, so this example, this is the first time I've run it with the Workspace browser actually open. It doesn't work as well because I was going to poll you for your thoughts on what A would be, but of course we can just see what A is. So to walk through this code, I'll run this first line, A equals 1. And here, I'm actually going to just clear my workspace. Oh, yeah. There's a little button in the Workspace tab called Clear All. And that just lets you erase everything from memory that you've created thus far. And that's actually how I want to, it's giving me a warning because that can be very dangerous sometimes. For the purposes of this tutorial, it's okay for me to have done that right then because I want to start this example from fresh. So first line says A equals 1. The next line says B equals 2. So the first line creates a new object called A, puts in it the value 1. The second line creates a new value called B, puts in it, or creates a new object called B, puts in it the value of 2. Now, if I say A equals B, a lot of people get tripped up on what this will do. Some people think that it will create or a lot of times people will think that it will create some sort of connection between the objects of A and objects B. That actually happens in some programming languages. But in the case of R, all that happens when you have an assignment where you have A equals B is that R will look in B. So it will look in the workspace. It will look in the object called B. It will see that B contains something. And it will take that something. It will create a new object called A, erasing A if A already exists. And in that, put the contents of what B had. Put a copy of the contents of what B had. So A equals B. If I run that, suddenly A will be turned into 2. Again, A will actually have been temporarily deleted and then created anew, and then a copy of the value 2 from B will be put into A. So the end result here is that whereas we started out with A equals 1, by changing basically doing this second assignment to A, we've erased what we put in A in the first place and put in a copy of whatever we put into B. So another way of showing what's in A is calling the print function. You can either just type it, and that shows 2. You can look in your workspace, and it shows 2 there. Or I can say print A, and that will also show 2. Different ways of doing the same thing. Now that we have this workspace, we don't really need to print. So the example 8 is intending to show that assignment is impermanent. We've kind of been seeing that throughout the code thus far because we've been assigning a whole bunch of things to A, and each time it changes. Here, this example had a slightly more complex scenario where we are actually assigning to A the contents of some other object in memory. This second example, example 9, demonstrates that when you do that procedure of creating or copying something from one object to another, you're not creating a connection between the objects as you might be in some programming languages. So this example, again, I'm going to clear the workspace because I want to start afresh. So I say A equals 2, and we get in our memory an object called A with a value of 2. And then I say B equals A. And what that will do, it will create a new object called B that's empty, and then it will go in A, look at what the value in A is, and create a copy of that value and put that into B. So now we've got this thing, B equals 2. Or sorry, B has a value, the object B is storing a value of 2. Now if I change A, some people think that that should also then change B, that this assignment of B equals A has created some sort of relationship between A and B, but in R at least, that's not the case. All that's happened is that B has a copy of what A had at the time that B was created. If A changes in the meantime, B stays the same. So, is there any confusion on the idea of assignment, creating objects in memory and then modifying them? Okay. It's really important to sort of grasp that. I know. Yes, certainly. Yes, certainly. So, yes, exactly. So, yeah, that is one of the great ideas, or that's one of the reasons why we create assignments, is because it then allows us to have shorthands for more complicated computations. So, if we say A is greater than 5, R will go in, it will look at the object called A in memory, it will look for an object called A in memory. If it finds an object called A, it will look at its value, and if the value is a number, it will then try to compare it against 5, or it will just replace the letter A with whatever value it has. Yeah, exactly. So if I wanted to, for example, create an object called A and as a string, and then I said A equals 5, what R is going to do is it's going to search for an object called A, it's going to find an object with a string inside, and then it's going to say, hey, I can't do a numerical comparison with a string. So, Okay, so that's fascinating. I've actually not. So there's clearly some implicit conversion going on here. Let's see. If I'm just going to explore this for a second. All right, well, that's one that I think clearly is a somewhat silly default behavior. There's something being done in this comparison that's not being done if you actually try to do it explicitly. So I'm going to have to ask the R folks about that, why that's the default behavior, because it seems somewhat silly. My thought was that it would just give me an error saying you can't do that thing, but apparently you can, and I don't know why. So, pardon me? Yeah. Where was I going to go with that? Oh, the other thing is if I try to refer to an object that's not in memory yet, so if I say D is greater than 5, it will definitely give me an error saying you haven't created D. I can't see D in your workspace. So so the next section is to talk about built-in functions. So there's a variety of ways to simplify things in R. So with math, logic, and assignment, you can do anything. But it will probably take you a long time to do anything by just using those 3 tools. What will greatly simplify your task is the idea that there are functions. Functions are pieces of code that have already been written that may take input, do some computation, and provide output. So there are 3 types of functions that are associated with R. There's the built-in functions, functions that just exist within R as you've installed them. We've encountered a bunch of built-in functions already. So print is a built-in function, print A. Print accepts an argument, and what its computation is that it just tells R to print something to the screen. We also encountered the square root function. So the square root function is a shorthand for taking it, whatever value you give it, and exponentiating that to the power of a half. So I'm not sure if that's any less typing, but most of the time, a function's purpose is to save you typing by having a whole series of computations summarized by a single function that you can run. So another function that's, let's see, did we encounter any other functions up here? Okay, so another function that I can introduce to you is the C function. C, I'm pretty sure, originally derives from just concatenate. So if I say A equals C and then all this stuff, what's happening is that we're creating an object called A. So if we have A in our workspace, it's going to be deleted, and a new object called A is going to be created. It's going to be empty, but then immediately we're going to put into A whatever's on the right-hand side of the equal sign, and what's on the right-hand side of the equal sign is C with parentheses, so we know we're using the C function. And the values that we have inside the parentheses are called arguments. They're just values that the function is going to use for computation. The C function is pretty simple. It actually, it doesn't really do any computation. It takes the values you're passing it and turns them just into a list of sorts. In R, it's actually called a vector. Lists are special things, and I'll talk to you about them in a second. But it creates a vector of numbers. It's not vector in the same way that in physics you have vectors that correspond to, I think, velocity and angle. It's just a vector in terms of it's a one-dimensional array. So if I run these 2 lines here, A equals that, print A. what's going to happen is that it's going to print whatever it finds in A. What is in A is a numeric vector. Oh, interesting. So this is the first time we've had something in memory or that is not just a single value. So we've had a single value numeric values, single Boolean values, logical values, or single strings. But here we actually have been storing, as I said, C will create a vector of numbers, the numbers being the ones you gave it. When I click the A value, it actually brings up an editor window. You can actually on the fly edit this, so even though in my code I put it as 1, 32, 2, 3, 4, 9, maybe I think, oh no, I'm actually going to change that 9 to a 10 and save. A is being changed in memory. I would never do that, simply because I always like to make sure that anything I've done, any computations I've done, have an explicit history in my text file. If you start modifying your data objects in the workspace through this little editor that it provides you, you've done things that you're not saving a history of. And in that case, when you come back to redo the analysis, maybe you've forgotten that you went and you did this point-and-click stuff. So I tend not to use the point-and-click interface for modifying things. If I need to change something, I would actually change it either right there, or if something's been created, there's ways to modify them in the code afterwards that I'll show you in the next session. So I've modified that. I don't want it to be modified, so I'm going to rerun this. If I say print A, though, it will just print out the vector that I created. It just puts white space in between the values, which can be a little bit hard to read sometimes. But let's actually take a tangent and step back and remember what I said at the very beginning, that whenever you print, all the time thus far, whenever we've printed something on the screen, or we've had the result of a computation that had a single value, I told you this square bracket 1 was telling you that, well, there was just a single value there. But here we've got a computation or some function that yields multiple values, but yet we're still getting the square brackets 1 over there. So I kind of lied to you. The 1 doesn't tell you that there's only one value coming out. It means that in this row, this is the, I guess, item number of the first thing that you'll encounter. So basically, R assumes that you can count within a row. So that you can count, oh, there's 4 things there. But if you've got multiple rows, maybe it's too hard to count all the things in each row. So it'll give you a little index of how many things, or what the item number of the first thing in each row. So, for example, if I have a printout that has multiple rows, it can't fit it all in one screen, which is what I'm going to have here. So if I say print 1 through 50, the colon is a way of saying I want all the integers from one thing, from the number on the left-hand side of the colon to the number on the right-hand side of the colon. So if I asked it to just print out the numbers 1 through 50, it's going to print out a whole bunch of numbers, but then it's running out of space. So it has to just continue the printing on a new line. And here you can see that the square brackets 1 is telling you that this item here is the first element. Square brackets here is telling you that this item on this row is the 30th element. Now it just so happens, because I was printing the numbers 1 through 50, that the first element is 1 and the 30th element is 30. That doesn't need to be the case. So for example, in this next example, if I print the numbers the other way, 50 to 1, the first element is 50, the 30th element is 21. So the numbers in the square brackets are simply telling you what the index of the item is that starts that row. Gives you a feel for how many items are actually being printed in the first place. So, let's see. I'm going to actually stop there because we're going to stop at 10:15, have a half-hour break, and when we return, we'll talk about some other features of dealing with using the tools that I've described to you thus far in the context of objects with multiple values stored within them. All right.